Right, well, good morning everyone. Welcome back to the London Perl Workshop after such a long break. I want to talk to you about a project I'm working on at the moment called Perl Diver, which I'm hoping some of you might find either interesting or useful, maybe even both. As most of these things do, it's a bit of a story, and this doesn't work, so that's good. And that doesn't work. Right, so the story starts a long time ago in a galaxy far away. Actually, it starts in 2019 at the Perl conference in Riga, which some of you would have been at. Well, I gave a talk called Measuring the Quality of Your Perl Code. In fact, there was the last London Perl workshop was later that year at David Game College, which is over there somewhere. And I gave a similar talk at that. In it, basically, I put forward the idea that in order to improve something, you need to measure it. You need to have numbers, and then you can make some changes, you can measure it again, and see whether things have got better. So we needed to come up with a set of values that you can track over time to measure the improvements in your code. And then you can plot graphs, which is the kind of things that managers love to see. Then I pointed out that there are actually no numbers that directly and accurately measure the quality of your Perl code, which would lead to a pretty short talk. So I came up with the idea of proxies for code quality. I'm not saying for a second that any of these things measure directly the quality of your code. I am saying they tend to move in the same direction as the quality of your code. And if you measure these and plot graphs on these sorts of things, you can measure how much better your code is getting over time. And I introduced the idea of continuous integration, the idea of every time you commit something into your code base, you run a bunch of tests or you run some kind of processes that produce measures of those four quality proxies. And by the end of the talk, I suggested that we could use Travis CI to run tests. We could use Travis CI in conjunction with coveralls to measure test coverage, and we could use Critica to run Perl Critic against our code base and to measure the cyclomatic complexity. Now that was 5 years ago. Unfortunately, in the intervening time, Travis CI, it's still there, but they've taken away their free tier, so no longer exists. And Critica closed down. They just couldn't afford the hosting costs, as I understand it. Coveralls are still there though, so yay to them. So hold that thought. We'll just put a pin in that story at that point. And another story, a long time ago in a galaxy far away. I actually mean last summer in Toronto. The TPC in Toronto actually went to a North American Perl conference for the first time ever, I think. And I gave a talk called this. I know at least one person in the audience was there live. A couple of people in the audience were there live. Some of you may have watched the videos. In fact, if you've followed what I've been doing over the last few years, you might know that GitHub Actions has become something that's really quite interesting to me. I wrote a book about it. But also, if you had access to my Google Docs account, which of course none of you do, you'd know that there's also the beginnings of a draft of a sequel, which is about GitHub pages. Because when you put GitHub Actions and GitHub pages together, some quite interesting things can happen. That's where the magic happens. So you can use GitHub Actions to run a CI process that writes the data to a database. Then you can generate a website from the database and then host that website in GitHub pages. This is the sort of vague idea that popped into my head about 15 months ago or so. So before we can move on completely, let's do a little bit of revision. What is CI? What is GitHub Actions? What is a build radiator? And what is GitHub Pages? Is that a single noun or a plural noun? Who knows? CI stands for continuous integration. Well, as I mentioned a few slides ago, we're talking about processes that run generally whenever you commit something to a code base. So it's encouraging developers to push their code back to the repo quite frequently. You'll get automated testing, you'll get fast feedback on anything that might be wrong when they take their changes and integrate it with the rest of the code base. It encourages collaborative development, and it gives you early detection of issues. I'm sure you've all been using continuous integration for a while now. The best thing about it is that you set it up and it all just happens automatically. Some CI systems you might have heard of. It's been a long time since I've seen a client that uses Jenkins. Maybe some people still do. Travis CI I already mentioned. There was a while when everyone used it for open source stuff, but they don't do free stuff anymore. So Circle CI, and then GitHub Actions is, I was going to say the new kid on the block, but it's been around for a few years now. It's quite a mature product. Which moves us on to our next question: what is GitHub Actions? Well, it's a CI system. It's actually built into GitHub. It allows you to run any code that you want in response to a number of triggers, things that happen to your repo. You can trigger on time and date, so you can basically running a cron job on GitHub's infrastructure. You can trigger events when you get a commit pushed, when you get a pull request, when someone raises an issue, all sorts of things that can trigger code running automatically on GitHub. Where does it run? Well, GitHub gives you standard runners that you can use to run your code. They're basically VMs. There's a Linux, by which I mean Ubuntu. There's a Ubuntu one, there's a Mac one, and there's a Windows one. But on top of those VMs, you can also run a Docker container, a Docker image. And you can even use self-hosted runners. You can set up GitHub's code so that it runs on a machine that you've got on your premises or in your data center. What can you run? Well, you can run pretty much anything. You've got a Docker container effectively, so you can run any code that exists in your repo. You can install other tools because it's connected to the internet, so anything that you can just run a command line installation. So you can run tests and linters and things like that. And you can also run static site generators. So we start to see the things that we needed in order to make my ideas come true. Okay, next question. What is a build radiator? I don't know. It's a term that I've been using for about 10 years, but I don't know. Maybe I've never heard anybody else using it. Maybe I made it up in a dream. But basically, it's the idea that you have a screen pinned to the wall near your team, and it will generally page through a number of different screens showing graphs and information about your project. So it might show graphs of the quality, proxies. It might show things like the number of issues you've got in your issue tracker at the moment, or how long the longest issue tracker has been waiting. So it's on a screen that everyone can see. It's next to the team. Teams can see their progress and be aware of things that are going on in the project. And management loves seeing this kind of stuff. It makes them think that they are in control. They're not, but it makes them think that they're in control. And we can build this with GitHub Pages, which is the last of our 4 questions. GitHub Pages, some of you will have probably have used it, I expect. Web pages stored in your GitHub repos and then hosted on GitHub's servers. They are static web pages. The whole point of them was GitHub gave us them so that you could easily build a website about your open source project that is stored on GitHub, and then it generates that, and you've got a user-friendly front end to your project, and it's also stored inside the GitHub repo. I'm a moderator on the Reddit for GitHub, and the number of questions we get when people who are not developers, who know nothing about programming or building applications, come to the subreddit because they think that GitHub is a source for them to find apps. They think it's basically an app store, and then they get very angry when it isn't. When what's this download? How do I clone? So GitHub Pages was intended to make it easy for projects to build websites about their projects that are aimed at the end users. But it's static websites, by which I mean HTML, CSS, JavaScript, images, PDF files, downloads, that kind of thing. But no back end whatsoever, no Dancer apps or PHP or anything like that. So, but that's not necessarily a restriction when you think about some of the other things that we've got. I've been talking for a few years now. I've written a few blog posts about this, about the idea of a semi-static site. And what I do is I use GitHub Actions to build a GitHub Pages site. And you can do that, like I said, GitHub Pages can be, so GitHub Actions can be triggered on a schedule, like a cron tab. Or when you push a change to your repo, you can run a GitHub action that checks out your code, builds the website, and automatically pushes it onto the GitHub Pages servers. So for example, many years ago, Planet sites were fashionable for about 3 weeks. And I still run a thing called Planet Perl, which is an aggregator of RSS feeds or Atom feeds about Perl. So it's got a list of RSS feeds like blogs.perl.org, perl.com articles, other blogs that people write that aren't on either of those places. And every 3 hours or something, it wakes up, it checks for new data on those feeds, rebuilds the website. But also, if I change the HTML templates, then once I commit those, it rebuilds the website. Or if I change the code, or I fix a bug, it rebuilds the website. So what is actually on the website at any given time is static. But by rebuilding it on a schedule, it appears like it's a bit more dynamic. So it starts to look like we've got all the pieces in place to replace things like Travis CI and Critica. So we can run GitHub Actions we can use GitHub Actions to run our CI processes, run them in a strictly controlled and specific manner, generate that data, store that data in a database, and then we can use GitHub Actions to generate a website using the data that's in the database, generate the pages, and publish it to GitHub Pages. But of course, the devil is always in the details. So I took that description and I described that architecture to ChatGPT, and I asked it to draw me a picture, architectural diagram, and it came up with this, which is slightly confusing, but also kind of fun. And actually, I haven't got them out, but I've got some postcards with this printed on. So if you want a souvenir of the talk, just stop me or take one at the end of the talk. But I tried again. I found a thing called eraser.io, which is an AI who exists to draw architectural diagrams, and we tried again, and it is better at this than ChatGPT. Who knew? And it came up with this. Now, my clicker didn't work. Maybe the pointer will. Too bright. Okay, that was a waste of money. So what we've got here, basically we've got the Perl Diver repo. There are 3 repos involved here because there's basically 3 pieces of software. There's the Perl Diver repo, which is where I've got all the code for Perl Diver. And that really purely only exists to generate a Docker image. There's an authentication server, which we don't need to really go into details about, but I'm thinking ahead for when I don't want people using it all the time. And then here is your application repo, or your code. And we need to add into your application repo a GitHub Actions workflow. Now, we'll see an example in a few slides' time, but a GitHub Actions workflow that defines how GitHub Actions works in your repo is just a YAML file. We all understand what YAML looks like. And it fires, presumably, when you commit and push a commit to your repo. And it has a plugin. Perl Diver has a plugin-based architecture. So there's a plugin that runs your tests. There's a plugin that looks for test coverage. There's a plugin that does linting with Perl Critic, and there's a plugin that looks for the psychometric complexity of your code. And rather than, if you normally run a Perl test plan, then on your screen it will write ran 159 tests, OK1, not OK2, OK3, etc. Instead of doing that, it catches the output and writes it into this database, an SQL-like database, which is actually stored in your repo. Then GitHub Actions, having run all the plugins, then goes away and generates the website using the data that is now stored in the database. It commits the new version of the database back to your repo so that you've got a history of the data, so you can draw time graphs. And then it publishes that website to GitHub pages. Yes.
So the website is retrieving the data from GitHub rather than having a database running.
No, the website, when it's live, when the website is published, it's a static website. So the last step, or one of the last steps that Perl Diver does is it interrogates the database, pulls all the data, draws tables and graphs and stuff, and then produces static pages. I mean, I guess you could pull it in from JavaScript or something and draw it, but there's no point.
Anyway, on the question, SQL-like database, that's a temporary thing in your Docker image, or where does that fit?
So, that's a good question. When a GitHub Actions workflow starts up, it's running. So it's running on the Ubuntu GitHub Runner VM, but, and we'll see in a second, it's pulling in a Docker container which runs Perl Diver. But I think in every single GitHub Action workflow that I've ever seen, the first thing that you do is you check out the current repo locally. So you've got both the Perl Diver code, which exists burnt into the Docker image, but then you check out whatever the repo is that we're working on. And that repo contains the SQLite database for that repo. So so having run all these tests and written stuff to the SQLite database, GitHub Actions has permissions to commit to the repo. So it adds another commit to the repo that has the latest version of the database.
That session goes, the data is gone well.
Well, except the version of it that's now committed to the, because it does a commit and a push.
It's an SQL.
Sorry?
It's an SQL.
No, it's the binary database. It's only an SQLite database. It's tiny. I mean, I guess if you're running this 100 times a day for years, it might get bigger, but we'll cross that bridge when we come to it. Yeah, so as I said, there's 3 GitHub repos involved. There's the Perl Diver code, which is really just used to build this Docker container. There's the authentication server, which is spelt wrong. And then there's the repo that contains your code. So we need to add a few things into your repo for this to work. The workflow definition, which will be standard as far as I can see. I'm still working on that at the moment, but I think there's no need for it to be anything other than standard. The database that we've just mentioned, and also you need to turn on the GitHub Pages configuration, which is just something that you do once. The GitHub action is a YAML file. It defines when the workflow is triggered and what the work file does. So those of you that haven't seen it, haven't seen what a GitHub Actions workflow definition file looks like, it's got a name, it says on, it says when it runs, and we've got 2 options here. We're saying push, so when a commit is pushed to the repo, it runs, and secondly, workflow dispatch. Basically, on the GitHub UI, on the page for actions in your repo, it just adds a button saying run the thing now, so you can just run it at any time by hand. And then the jobs, and like I said, you have a number of jobs, give it a name, tell it runs on the Ubuntu VM, and then pull down the latest version of my Perl Diver container. And then the steps within that job, as I said, the first thing you always do is you check out the repo, and there's a standard GitHub action for doing that. We run Perl Diver, passing it some information that is available to you inside GitHub Actions. This is the name, so the owner/name of the repo, which you can always access within a GitHub action. And then you need an API key in order for the authentication to work, and you just store that in the secret store for your repo. And when you sign up to use Perl Diver, I give you an API key, and you store that in your repo. Then you commit the database. Like I said, you need the database has changed. And then you do stuff that you basically updating the pages artifact is taking everything that's written to a subdirectory in your checkout. So in the docs directory, builds basically a big zip file or a tarball or something. And then a second job called deploy takes that tarball and deploys it to GitHub Pages. So actually the output, the HTML files never actually get stored in your repo. They get built on the container. They then get bundled up and sent off to the GitHub Pages servers, and then your container goes away. Thesis 2 exists. Yeah, so it's a small SQL database served it's stored in the .db directory. And something that slightly worries me about this whole plan is that there are no user serviceable parts inside that database, but you have access to it. So, I guess if you break it, you get to keep both parts. So the website is written to the docs directory, then uploaded to the server, not checked into the repo. By default, GitHub Pages website is accessible at your username.github.io/the repo name. Now, there's some thinking going on in the back of my head of what happens if you already have a GitHub pages site stored inside your repo. You probably need to put a Perl Diver subdirectory in there or something like that. And you need to do some setup to make pages work. Right, what does the website look like, Paige? Well, I'm glad you asked. But bear in mind, I am not a web designer, but Bootstrap and GitHub Copilot really help. I don't know, you can maybe tip for later, maybe turn the lights off in this room. Basically, in order to test this, I've got a plugin that basically just counts the number of files. Oh, thank you. That just basically counts the number of files in the repo, so that's stayed static across the time. But you've got tabs for each of the plugins that it uses, and then you can see the pod coverage increases. And there'll presumably be 4 or 5 different plugins along here. And then I need to think about a front page to guide you gently into this, but this is still a work in progress. But so that was using chart.js, which I didn't know anything about, but Copilot did, so that was cool. And then I'm planning there's a default display mechanism for simple plugins, but plugins will be able to override any part of the output. In fact, they can just completely take over the output of the graphs completely. Yeah, so there will be this plugin architecture with standard plugins that come pre-installed for the quality proxies that I've talked about. Other people will be able to write plugins once I've documented how it works. Plugins basically stored JSON in the database, so it doesn't matter how complicated the data is that a plugin wants to store, because it just goes into a text field as JSON. So some conclusions. Code measurement is cool. Code measurement is useful. Managers absolutely love this stuff, and Perl Diver makes it nice and easy. I think I have 5 minutes, or maybe a little bit more because we started late. Contact me, perldiver.dev. There's a start of a website. Take a postcard. And has anyone got any other questions?
Are you wearing a Perl Diver t-shirt?
Am I wearing a Perl Diver t-shirt? I love Redbubble.
So is this live now then?
Is it live? No. It's still a bit of a work in progress. Presumably in choosing to come to this talk, you read the description, which I put on the website when the call for papers went out 6 months ago, and I said, depending on how the next 6 months goes, this will either be a really cool talk with lots of demos, or it'll be a bit hand-wavy with ideas about how it works. And we've fallen somewhere between the two. But a lot of my attention over the last couple of months at least has been distracted by a book, which we'll be talking a little bit about in the lightning talks later this afternoon.
You have Critica, I'm not also Critica, but one of the things that you had right at the very beginning.
Yes. Coveralls still works. Yes.
So does your container access coveralls or
No. In the Perl Actions talk that I gave in Toronto last year, which is on YouTube somewhere, I talked about writing some standardized Perl development GitHub actions. And in writing that, I have an action that you can reuse that works out your code coverage and then sends that report off to coveralls and so displays it. So all of my CPAN modules at least have code coverage that's generated on every push and sent to coveralls. But Perl Diver is going to take a slightly different approach, because I think it's important to have all of the output looking the same and contained within the separate Perl Diver website. So it will, I mean, I might borrow some of the way that the code coverage, although actually one of the times that I gave that talk, Paul Johnson was present. Paul Johnson wrote the Perl test coverage stuff. And he came up to me after the talk and pointed out that, I can't even remember what his module's called, test coverage or something like that. Davorg coverage, yeah. That actually contains information at a far more detailed level than coveralls needs. Coveralls, I think, works, can't remember, but he said it has better information. So if I, for my coverage report in Perl Diver, if I look at the graphs that Paul's coverage module develops, then they will be better than the ones that Coveralls uses, because Coveralls supports all sorts of coverage tools across all sorts of languages, so it's kind of a lowest common denominator thing. So I think we can do better, is what I'm saying.
Will people who are using Perl Diver have the option to disable the default plugins and choose the order that the tabs appear? So could you completely customize what you're displaying?
I mean, not at the moment, but yes, that is something that I've been thinking about. There will be, I mean, I guess what we'll end up with is, I talked about the few things that we needed to add into your repo. If we put a perldiver.yaml file at the top level of your repo, I can't see that being a problem.
If you have an authentication server, is that to have you access pages only if they're pass authentication?
The way the authentication server currently works is it controls the access to running Perl Diver. It doesn't control access to the generated pages. I mean, I'm kind of assuming that you would use GitHub's existing mechanisms for doing that, for controlling access to GitHub pages sites. But it's an interesting point. I hadn't really thought about it, that maybe they default to public and you don't want that to happen. So yeah, maybe.
So with the authentication, is the intention to charge?
Eventually, yes. I mean, if you go to the perldiver.dev website now, there's some sketches of costs, and I'm thinking free or peanuts for small open source projects. But you know, if Booking.com wanted to use it, yeah, I'd gouge them. Any other questions? Well, thank you. Thank you for listening.